Hello and welcome back. Today I'll be going over exponents and their properties. Now, what exactly are exponents used for? An exponent is simply an easier way to represent the amount of times you multiply a number by itself. To understand this better, let's look at what multiplication is. If we have 10 times 3, what we're doing is 10 plus 10 plus 10, which is known as repeated addition. But when we're using exponents, we'd be multiplying instead of adding. So if we had to do 10 to the power of 3, we'd be doing 10 times 10 times 10, which is known as repeated multiplication. But what does the tiny and the large number mean here? The large number is what you'd refer to as the base, which is the number getting multiplied. The smaller number, or the exponent, is the amount of times you're multiplying the base by itself. We refer to numbers with an exponent by saying the base value to the power of the exponent value. So here, we'd say 7 to the power of 4, or 7 raised to the power of 4. If your number is to the power of 2, you could say squared instead, and if it's to the power of 3, you could say cubed. Let's try to solve a question involving an exponent before we look at exponent rules. Our question here is finding out what 4 cubed is. Well, as said previously, 4 cubed is 4 to the power of 3, which is telling us what we have to do. We have to do 4 times 4 times 4. Well, first, 4 times 4 is 16. Then, we do 16 times 4, which is 64, which is our final answer. That wasn't that bad, was it? Let's move on to the special exponent rules. The first one involves multiplication. It's basically saying that if you multiply two numbers together with an exponent that have the same base, all you have to do is add the exponents together to get the answer, and you keep the base. Let's see an example. We have 5 cubed times 5 squared. Well, since the numbers have the same base, we add the exponents together. 2 plus 3 is 5, meaning that our final answer is just 5 to the power of 5. Let's try out another problem. 6 to the power of 4 times 6 to the power of 8. Both of the bases here are the same, being 6. So what we do is we add 8 and 4, giving us 12. We keep the base and get 6 to the power of 12 as our final answer. Now that we've gone over multiplication, let's go on to division. When you divide two numbers with exponents that have the same base, you subtract the exponents. Let's look at an example. 6 to the power of 5 divided by 6 cubed. So what do? We subtract the 3 from the 5 to get 2 as our exponent value, meaning that we keep the base and get 6 to the power of 2 as our final answer. Let's look at another problem. 4 to the power of 6 divided by 4 to the power of 2, or 4 squared. The bases are the same, being 4, so what we do is we subtract 2 from the 6 to get 4 as our exponent value, meaning that our final answer would be 4 to the power of 4. Now we've been looking at rules that apply when our exponent is positive, but now let's look at what happens when our exponent is equal to 0. Whenever we have a number to the power of 0, it's going to equal 1, but let's see why. Let's take a variable x and a variable for our exponent y. We now have x to the power of y as our number here. First, let's do x to the power of y divided by x to the power of y. We know that if we divide anything by itself, well, besides doing 0 divided by 0, we get 1 as the answer, meaning that x to the power of y divided by x to the power of y is equal to 1. Now let's look at the division exponent rules we talked about. If the bases are the same, we can simply subtract the exponents. Here, the numerator and denominator share the same base, x, so we can simply subtract the exponents. Y minus y is going to be 0, as if you subtract anything from itself, it's going to be 0. This means that x to the power of y divided by x to the power of y can also be x to the power of 0. We know that x to the power of y divided by x to the power of y is equal to both 1 and x to the power of 0, meaning that x to the power of 0 is equal to 1. Since x is a variable, we can input any number besides 0 and it will be true, proving that any number to the power of 0 is going to be 1. Now that we've gone over what happens with positive numbers, let's see what happens with negative numbers. When you have a negative exponent, what you want to do is actually flip the number upside down to make the exponent positive, or you take the reciprocal of. This may sound confusing, so let's look at an example. 5 to the negative third power. First, what we want to do is flip the number upside down. When you take the reciprocal of 5, you get 1 over 5. And as we're making the negative 3 positive, we're going to get 1 over 5 to the positive third power as our answer. Then, we can simplify this. 5 to the third power, or 5 cubed, is 5 times 5 times 5, giving 125. This means that 5 to the negative third power is 1 over 125. Let's try this with another example. 7 to the negative fourth power. Since this is a negative exponent, we flip the number over to get 1 over 7 to the fourth power. We then do 7 times 7 times 7 times 7, which gives 2401, meaning that the final answer is 1 over 2401. Those are the 4 basic rules of exponents that you have to know for now. In another video, I'll go more in depth into the other rules of exponents. Thank you for watching, and if you have any other questions, feel free to leave them down below.